So now we are going to discuss some properties of this free expansion. And here we are having two chambers 1 and 2, and this is insulated, thermally insulated by using some boundary. Now we are having a pipe connecting these two these two vessels, and there is a wall in this pipe. And now initially there is the gas only is present in the vessel 1, and vessel 2 is evacuated. So what we do is we will be opening this valve such that now the air will be flowing to the vessel 2. Initially at the pressure, the vessel 1, the pressure was P1. Now the air fills both these vessels and pressure will be some say Pt, and that pressure will be lower than this P1. Now here we know for a system, if we are supplying a net heat Q, there will be two processes. One is that we will get a work output, and second one is that while supplying a heat, a part of this heat will be absorbed by the system, fluid in the system, and there will be a rise in temperature, and that is the internal energy, and a part is given out as the work. So that is being given as Q is equal to U2 minus U1 plus W. U2 minus U1 is the internal energy change because of this heat addition. Now here in this system, since it is well thermally insulated, there is no heat addition to the system. That means Q is 0, net heat added is 0, and work, since the volume is constant, that means there is no moving parts. Like in piston and cylinder arrangement, there is a moving part, but here there is no moving part, and the volume is of the system is being kept as constant, so that we do not get any work output. By simple looking, we can say that we are unable to derive the work. That means work is 0. That is Q is 0, work is 0. That is U2 minus U1 is equal to 0, or U2 is equal to U1. U2, internal energy, is a function of temperature, and that is equal to Cv into T. It's already known to us. So actually it is Cv into T plus constant K. So U1 will be Cv T1 plus K. U2 will be Cv T2 plus K. So we know U1 is equal to U2. So we are supplying these two values here, and at last we get Cv2 is equal to Cvt1, and this Cv and Cv are cancelled, so we get T1 is equal to T2. That means here before the expansion the temperature will be T1, and after we are opening the valve there is expansion, and after this free expansion is completed, we are getting the temperature. The temperature of the system after the free expansion will be T2, that will be same as the initial temperature. That means after and before free expansion the temperature remains constant. That is the peculiarity in the free expansion. Thank you.